Okay, let's get started. So we didn't finish our D3 lecture on Thursday, so we'll finish it up today, the second part, and then we'll jump into today's lecture. So we probably won't finish that one because this ran over. So we'll catch that one up on Thursday. That'll probably push our D3 lecture and so on and so on. But we'll see what we can do. So if you remember, this is that maps and layouts lecture in our lectures code repository. So on Tuesday, we looked at some color examples. So we looked at this page here. We looked at different ways to do color scales, and D3 has some kind of interesting like quantile scales, ways to threshold scales. Then we talked a little bit about some layout generators, like the histogram, right, is a way to basically, you take your raw data and you create some derived data attribute, right? So for a histogram, you bin the data into groups or segments or bins, right? And you visualize those bins and the counts for each bin as a bar chart. So a density chart, right? That was the other example we did. You use a density function to estimate. Instead of using a bar chart to do it, you can apply a density function and visualize it that way using an area chart. Then we also looked at a donut chart. All right, so D3 has lots and lots of layouts. If you want to use a layout, like in your project, right? I want to create a chart that requires a layout, like a pie chart. The best way to figure out how to do it is go read the documentation or go look at examples online that show you how to do it. Now, the one thing you might want to be a little bit careful about is that if you're looking at an old code base, like pre-V7 code, sometimes there's syntax issues. V5 to V7 are pretty similar, but before that, the codes actually gets a lot different. So most of the time it will work. Very occasionally, if it's an old version, it won't. So just keep that in mind. Yeah.
So I don't think that it's any other version 7.
Yeah, okay, yeah. So there are certainly differences between V5 to V6, V6 to V7. Like the way that events are handled is one example of that. So like in previous ways, you could say like D3.event, but now it's just event. So like if you're like handling a mouse click or something. So that's one example that changed since V5. So, Googling it like with V7 would probably be my strategy if it's not working. Or you can go read the documentation. So, we don't read a lot of documentation during classes, but that is actually a really good skill to have, like from an industry perspective, right? If you have the ability to go read an API or read documentation on a project, that's actually a very important skill. And a lot of people, you will probably find a lot of your coworkers maybe aren't that good at it. So if you can do it, it's frustrating, but it's also a way to get ahead, right? Being able to do that. Okay, enough for that poetic waxing. Okay, so today we're going to look at the second HTML file in this folder, and it's the maps.html file. So this one right here. Okay, so I went ahead and loaded the file so that if you pull it up on your local machine, this is what it's going to look like. And it's some examples of drawing maps using D3. And so there's some different examples of projections, right? So we talked about when you're visualizing a map of the Earth, right? The Earth is a 3D sphere. So to convert that 3D sphere into something that will display on a 2D monitor, we have to run the map, the geographic boundaries through a projection. Right? And so there's some different projections we can play with here, like Mercator is here, and some other ones. So we're going to look at that. Then we have two more examples. One, kind of extracting information from a map. So we can click on this and extract just the information for a state or overlying data on a map. And then finally, just an example using the leaflet library, which is a tile-based library. So you can, this is an alternative to doing something like this GeoJSON approach, where you're actually drawing, right? For the US map, we're actually drawing it as a bunch of shapes. So there's a data file that actually draws all the outlines of the shapes for all the states. In Leaflet, you're actually using a library to load a bunch of PNG files that are stitched together in a way that makes a map. So if you zoom out, you can see that the files get reloaded. You know, if we move, the files get moved around. So that's kind of the alternative to drawing a shaped file map is use a tile-based map. Okay, so let's jump into this. All right, so just to quickly go through this code. So here's our head, the head of our HTML file. So we're going to link to Bootstrap and D3. We're also going to link to the D3 GeoProjection library. So this so D3, kind of the base D3, comes with several map projections, but there's even more than that. And so this library will give you access to lots and lots and lots of projections. Right? So like several dozen projections that are available. So you can see lots and lots and lots of projections. So that's what this is going to do. And then this is a link to the Leaflet library here. Looks like I had Bootstrap in there twice. Shouldn't have done that. Right, and then a link to the Leaflet CSS here, and the Leaflet JS file here too. Okay, so that'll let us run the Leaflet library. Then we just have some CSS here. So I'm using this to style the SVGs. I'm giving them a border. So that's why the SVGs have a border. My HTML elements, I'm just making them as wide as they'll go in the divs. So what this is going to do is it's going to set the stroke or the border of each country or state is going to be black border with a width of 1, and then the fill color is going to be this nice honeydew green color. A graticule. Does anyone know what a graticule is? Anyone ever heard that term before? So a graticule are these latitude longitude lines. So like the lat long lines are the graticules. And then the boundary is just this black border on the map. So the overall map, we're going to draw a black border around it. Okay, so those are kind of the elements we're using to build our map. Okay, so going into the body. So we're using Bootstrap, so we're going to open up a container, right? And then at the top here, we have our header. So this is our map examples. And then a subheader right here where we talk about the projections navigation. So we're going to demo a couple of different ways to do projections and navigate, that is zoom and pan, around a map. So then we have a dropdown right here. So that's this dropdown here with the different, so these are different map projections that we can use. So if I wanted to add more, I could go to that projections page and just find one I liked and add it here. We have a reset zoom button. So if I zoom in or pan, that will take us back to the beginning. And then we have this GeoJSON map SVG, which is this first SVG right here. Okay. All right, so opening up a JavaScript block. So this is pretty boilerplate code by this point. We'll get a reference to the SVG. We'll check. So we're kind of dynamically setting the width of it based on however wide the browser window is. That's the client width. So we're getting a reference to that. This is going to store our GeoJSON data set. So the countries in this that we're visualizing here, this data has to come from somewhere. So it's stored in what's called a GeoJSON file. And so this world data is the variable that we're going to use to store that. Okay, so just like it's a scatter plot or a bar chart, we're going to import the data and save it into a data structure, and then we just draw it on the screen, almost like a line chart. We're going to draw it as a bunch of lines or a bunch of paths. Okay. So a GeoJSON file, this is where we're going to load it right here. So we say d3.json. So that says load a file that's of the type JSON. So not d3.csv, but d3.json. So import a JSON file. So we're going to import it and store it to this temporary data variable. And then we're just going to save it to that world data variable. Okay. And then once it's loaded, we'll just call it update map. That's what's going to draw this world map here. Okay. Now I've got a big comment here. So this describes how a GeoJSON file is structured. All right, so let's pull that over a little bit. So GeoJSON files, so just like it sounds, it's a JSON file that stores geographic information or geographic boundaries. So it could be countries, it could be states. Down here we have a GeoJSON file that stores all the states. And this is how the data is structured in the file. Okay. So if we go look at our world.geojson file. Okay. So this is not very well. Come on, let's quit lagging. Okay, so so the way that it's stored, the very first thing is going to be a metadata label. We'll say type feature collection. So it should say that right here, right? Type feature collection. And then the features is going to be a list of each feature is going to be one country or one area, country, state, whatever our granularity is in our data set. Okay, so you can see here like type feature, properties name Afghanistan, and then there's a geometry tag. So that geometry tag is going to be basically a bunch of XY coordinates that draw the shape of that country. Okay, so you can imagine like fewer coordinates, right, is going to be a less precise drawing of the country, but your GeoJSON file is going to be smaller. So if you want to draw a GeoJSON file, like you may look at different, there could be two US GeoJSON files. One of them could be like 50 kilobytes, pretty small. Another one could be like 50 megabytes because it's really, really detailed. Okay, so that just means probably they put a lot more precise drawing of all the geography.
So we could just pick the one that is best for our users.
So like if you're doing a map for your project, probably you can pick one that's a little bit smaller, right? You don't need a 50 megabyte file for your project. You can probably get away with doing a less precise one, is my guess. All right, so each feature, so we have an array or a list of features. Each feature is a region or a state or a country. So the geometry is just a list of the coordinates that draw the border. Miscellaneous, so properties are just miscellaneous kind of metadata properties. So in the world GeoJSON file, the only property that it has is the name. So you can see, go back to the side here. You can see there's the property name Angola, name Albania, name UAE, Argentina, and so on, right? So properties, depending on the GeoJSON file, right, they could have lots of things. We could have like population or demographic information or the name of the capital city, something like that. In this case, it's just the name of the country. I think let's look in this one. Yeah, okay. So here's another one. Here's a US GeoJSON. We'll look at this in a minute. So you see here in the properties, they actually have a bunch of other stuff, like a link to the Wikipedia for the state, right? So you can kind of put whatever you want in here. For our case, we're going to read the name of the country. Okay, so that's how GeoJSON data is stored and how it should be stored if you want to draw it in D3. Okay, so we import the data with this D3 GeoJSON. We import it, we save it to this global variable, and then we'll just say update map. All right, so update map is this function right here. So we say draw or update Okay, so if the map doesn't exist, when we load the page, we'll draw it. If it already exists, we're going to update it. Okay, so we're gonna do this using a join, right? So we'll update it based on the current projection that we're using. So if I change the projection, we'll actually reset the zoom and update. We use that update map call to draw the map or update the map. Okay, so the first thing we're going to do is we're going to say get the current projection based on the map projection select. Okay, so that's this drop down right here. So we're going to call a function that's going to get whatever the current projection is. So if we scroll down here and just look at this function real quick. So this is just a big if-else, bunch of if-else statements. Okay, so we're going to read the value, and if it's equal to the Mercator value, we're going to return a D3 projection for the GeoMercator map projection. If it's the GeoArray projection, right, so this one right here, Array, will return the D3 projection for the GeoArray map projection, and so on and so on. Okay. Okay, so that's what this get projection function is going to do. So it's just a bunch of if-else statements, and then there's I do a quick error handling at the bottom. So if you want to do error handling in your JavaScript, this is how you can do it. Okay, so let's go back up here. So this projection is going to be a reference to a D3 projection, a D3 map projection. Next, we're going to scale and position our map in the SVG. Okay, so there's two ways you can do this. There's the uncommented way and this way that's commented out. Okay, so this way right here, we're gonna use something called fit size. So what fit size is gonna do is it's gonna say, based on the current projection I have, fit it in the SVG based on, so based on the size of the SVG, make sure the map fits all the way in there with 50 pixels of kind of space, okay? So that's what fit size is gonna do. And then the translate is gonna, instead of drawing the map at the top left corner, we'll move it to the middle and draw it there. Okay, so that's how you can kind of do it in a responsive way, right? So if this is smaller and I reload the page, right, it'll draw the map so that it fits. If the page is bigger, right, if I reload it, it'll size it appropriately. Alternatively, if I comment that out and I uncomment this, so this is kind of an older way to do it before they introduced the fit size. So you can kind of manually scale it, can kind of center it. So the geocentroid is going to get the middle, so 0, 0 lat long, and then kind of push it so it fits. So not quite as precise. It's kind of tedious if if your SVG size could change. Fit size is much easier. All right, so we're going to go back to fit size. Okay, next. So we're going to get a D3 geopath. So the comment says, this is similar to a D3 line generator. And it is, because the country shapes, they're just a bunch of lines, right? And you connect it, right? So that's why we can fill it in. It's not like just a line, but it's actually like a path that connects. But it's very similar, right? It's a bunch of XY points, which are lat long points, and we're just going to draw those to draw the shape of the country. The difference is, right, remember, 3D world projected down to a 2D display. So we have to pass, so our lat long coordinates, we have to pass them through a projection, whatever our current projection is, like Winkel or Mercator or azimuthal equal area. We're going to pass it through that. And so that's actually what's going to give us the XY pixel values to draw on the monitor. Okay, so the projection, it's kind of like a scale, right? We go from a data space to a pixel space. Projection is the exact same way. We're going from like a 3D world space to a 2D pixel space on my monitor, right, through the projection. And so if I change the projection, right, the XY coordinates of the US, right, the way that we draw the US is going to change. Right. Okay, so that's what the projection is going to do. But in terms of like the way that you call it, very similar to like a line chart, right? We kind of define our geopath like we define a line generator, and then we're going to use it to draw the countries. Okay, so now we have a join statement. So we're going to use a join to add a country if it doesn't exist yet, or if the country does exist and we call this function, we're going to transition it or update it to a new position. Okay, so add it if it hasn't been added yet, right? So that means we're going to go into the inner bucket. Okay, so we would say, in that case, we would say inner append. We're going to append a path, right? We're going to draw a line using our geopath generator. Okay, so each feature, right? This features is a list of countries. So for each country, we're going to draw it as a path based on the geopath projection. And so that's what's going to draw it on our monitor. If the country does exist, right? Let's say it exists and I change the projection, right? If that happens, we'll go into the update bucket. The country's already been drawn. We're not going to remove it. Instead, we're going to update it. So for that, that's a little messed up. We'll do that. So to do that, all we're going to do is we're just going to call this geopath again. But because we've updated the country, like because we're calling this function again, like if we change our projection, right? If I change it, now the projection will be different. So that's why the countries will shift around, right? Because the projection's been changed. Yes?
Does JavaScript objects?
Does JavaScript have a concept of objects? Yes, it does.
So like if I want to link property, this was a thing on the previous homework too. Like if I want to link the line and the circle and the text,
Yes.
I want it to work together. There is something like an object that can animate the whole thing.
Okay, so the question is there an object? So in JavaScript, there's kind of two things that you look at. So this right here in our console, right? So I'm printing out something and it says objects. We'll assume it's an object. Okay, so if that console statement is coming from right here. Okay. So when I import my world.geojson file, okay, that's what I'm printing out here. Okay, so you can see it says object, then there's type feature collection, and then features. It says 177, and then there's a square bracket. Okay. So in JavaScript, there's strings, there's numbers, there's Boolean, and there's objects and arrays or lists. Okay, so type is a string. Features is going to be an array. Okay, and I know that because of the square bracket here. It is going to make it an array. Each item in the array is going to be an object. I know that because it's got a curly brace. A curly brace, okay? So then within each object, it has the following key values. So a key is just some key. The value can be any of those things. It can be a string. You can see there's a string up there. Like it can be another item. It can be another object. So like properties is an object that has another key value. So the name and then it's Afghanistan. It could be another array. So in terms of the JavaScript, yes, there are objects. Objects, it's kind of like a map. It's just a set of key values, right? So as to your question of like, for the homework, how did we, like what's the best way to do that? lots of ways to do it. Draw by office hours is probably the easiest way. Yeah, I don't know if that's a good answer, but yes, JavaScript does have objects.
What I ended up doing is like, I did the whole thing for all three, like a line for a circle and for text.
Yeah, that's not a bad way to do it. Yeah, on the homework, just doing them all independently. That's one way to do it. Yes. You just have to stage them in a way that is the same. Okay, so back to this. All right, so we were this right here. Okay, so we're using a join to draw our countries. Okay, so we're going to draw each country shape if it doesn't exist. If it does exist, but we update it somehow. So if we change the projection, or if we reset the zoom, we're going to call this update map function again, and so that means the update will get called. So it'll either update the projection or it'll recenter it back to kind of to like a 0, 0 zoom pan setting. So that's what this update's going to do. So you might notice there's no exit here, right? Because we're never actually going to remove the data. So I didn't need to put an exit here. I just have an enter and an update. Okay, so that's going to draw the countries. We're going to do the same thing for our lat long lines, our graticules. So this is going to look very similar. So we have a graticule data set, or we have a graticule data structure. And to get that, I can just say d3.geograticule. So that's going to import the lat long lines that we can draw. So d3.geograticule and then graticule.lines. That's just a list of all the lat long lines. Okay. So again, drawing them is going to look very similar. I draw them as a path. If they don't exist, if they do exist, I again send it through the projection. So that'll draw them, curved or straight depending on the projection. Same thing with the this kind of overall boundary. So for this, I'm getting the outline. So this is kind of the outline of the map itself. So I'm kind of doing this the old way, just appending it directly, just so I can get it kind of thicker, like a thicker bold color. Okay, so that's drawing the map. Now, a couple other things here. So let's look at zoom and pan. So we're going to add a zoom and pan functionality to our map, right? So if I can use the scroll wheel to zoom in or out. I can double click, I think, yeah, double click works to zoom in or out. Or I can click and drag and that will pan. Right? This reset, if I click the reset zoom button, it goes back to the kind of the default zoom and pan. Right, if I zoom in and move around and I change the projection, again, we go back to like the base view. So clicking reset zoom is just going to call the update map, or changing this is also going to call the update map. So it's going to zoom back out. So to add a zoom functionality to a chart, this is how you can do it. So we'll say d3.zoom. So this says we want to add zoom functionality to an SVG, to a chart. Scale extent is going to say how far in or out can we zoom. So you might notice, so if I scroll in, like eventually I can't go in anymore. Same thing going out, like, oops. That's as far out as I can go. And then, so on zoom, okay, so if I do a zoom, so if I click and drag, or if I double click, or if I scroll in or scroll out, we're going to do a zoom event. And so that's going to get captured here. So when that happens, I'm just going to say, for the countries, okay, for the countries that are here, so each of these I've added a country class to each path. Okay, so I've done that right here. Do it right there. So I added a country class to each of the countries on my map. So I'll grab those and transform them I'll modify them based on whatever I did for the event. So if I drag, then it's a pan event. If I scroll in or out, it's a zoom event. Okay, so I reference the item and I apply the transform, whatever the transform was, I'm just going to apply it. So I do that to the countries, I do it to the lat long graticules, and I do it to this black boundary. Right? So that's why all three things move if I'm doing panning or if I zoom in or out. That's why all three items on the map move. So I'm moving them independently, but they're all based on the same event. And then I just say GeoJSON. So the SVG, I say .call zoom. That's going to attach the zoom functionality to the chart. So you can do the same type of functionality on any chart, like a bar chart or a scatter plot. Right? It doesn't have to be a map. Any chart, it should work. Yeah.
Can we, if it's a bar chart or a scatter plot, when we zoom in, the axis should change?
So question is, if I zoom in on something like a bar chart, is the axis going to change? Nope, it's not. It will also zoom in, and the numbers will get bigger. Like the number will physically get bigger. Yeah, so if I attach a D3 zoom to a chart that has like an axis on it, the axis itself will zoom in. It won't like, the axis won't animate or modify. It'll be the same axis, it'll just get bigger. Yeah. Yeah, so if you wanted to do something that was like, maybe the axis like stayed there, kind of locked to the side of your chart, but like it actually zoomed in. So that would be a little bit more involved logic. You could do that, but it'd be more involved. So you'd have to capture the event and probably like read its properties and manually modify the axis and like make sure it didn't move around. You could do it, but it gets more complicated. I'm sure there's examples online of people who've done that. That's a good question. So the last thing is if this reset zoom button is called right here. So we're gonna run a transition that's going to call the zoom and just go back to what's called the zoom identities, like the default settings: 0 zoom, 0 pan. Right, so that's why the map gets centered back. So we'll transition it back, and then we'll call update map again. So that's why if I zoom in and I change the projection, first it's going to reposition the map, then it calls the transition. Right, so we're going to reposition the map. Once that's done, then we'll update the map, which will update the projection. Okay. Okay, so that's our first map example. Any questions about this so far? Okay, I know several teams are doing maps, like spatial data sets for their projects. So I think this code is a pretty good reference. So yeah, feel free to take it and run with it.
If it takes something, that's not.
Yes, if you reference code from our lectures in your homeworks, yeah, that would not be like plagiarism. Yeah.
What if you take, like, someone online has implemented something, and that's how it works in your code too?
Yeah, that would be okay. Yeah.
Copy the method and be like, I think it's.
Yes, that would be okay. Yeah. Okay, so let's look at our second example. Extracting regions and adding layers. So for this one, so this is just an example that the primary thing we want to do here is first show you how to add data on top of a map. So this show cities checkbox, when I click it, we're going to add a bunch of circles to show the capitals for each state. When I click it again, we're going to take them off. The other thing I can do is if I click on a state, we're going to extract just that shape's geographic boundary, just that state's shape from our GeoJSON file, and we'll draw that kind of in its own chart overlaid on top of the map. So that's what that's going to do. All right, so what are you doing here? So let's jump right into the JavaScript. So the HTML code here is pretty similar to above. We have a header, we have our checkbox, and then we have our SVG right here. So in the JavaScript, we have our boilerplate code to get a reference to the SVG, get the width and height. We have two data variables. So the map data is going to store the geographic state. So that's actually going to be the map shapes, the state shapes. The cities data is just a table of, let's see, it's this right here. Just the capitals of each state. So right, it's a very simple table data set. So each state, the capital, and its lat long coordinates. So that's what this USA cities data is. We also have a projection. So the projection for the USA map. Okay, so we're going to load two files. So we're going to use Promise for that. So Promise will wait until both files are loaded before we actually start running more logic. So we're going to load a US GeoJSON file. It looks just like our world GeoJSON, except it's US states. And then that table data set of the state's capitals. So we'll load both of those and store them to our two variables. Then we're going to define a projection for our map. Okay, so we're going to base this on a projection called GeoAlbers USA, and we're using this fit size to make sure the projection fits inside of our SVG window. So I have a comment here. Try switching this to see how the view. Okay, let's try that. See what it does. All right, so if I save that. Okay. All right, so if we change this from GeoAlbers USA to GeoAlbers non-USA, so now the data is going to be a little bit different. So this is interesting, right? So if I go back, I put the USA back, save it. All right, so this is like a very classic, like you took geography in 8th grade or whatever, right? Like there's a map of the US, right? And it always put, Alaska is like down here with Hawaii, right? Not really there, but right, to fit it in a nice poster, right? So Albers USA is a special projection that's going to take, if one of my boundaries, whatever my Alaska boundary is, that projection is going to move it like below California, Arizona, and shrink it so it fits right there. And so same thing with Hawaii, right? Hawaii is like way over here. They're going to put it over there and again, shrink it. So that's what Albers USA does. GeoAlbers, if I save that, right? This is like a true map of the entire world, right? Like actually where Alaska goes in the whole world, right? It's like way up there, right? You could imagine like Canada, if the GeoJSON file had Canada data, it would also go right there. So Albers is a projection I could use for the whole world, but Albers USA is one that's kind of like specific to, it just expects the USA states in our GeoJSON file. And so there's a couple of projections that do that sort of, that do that sort of stuff. Right, if you just show the USA, it'll kind of move Alaska and Hawaii. So that's what we're going to use. So we'll define our projection using our USA projection, right, our GeoPath, and then we'll draw the map and put a click interaction on it. So if I do a click, that's when we're going to do this. We'll draw the selected state that I click on, like that. Okay. Now there's a draw leaflet function. We'll come back to the draw leaflet in a few minutes. Okay, so when a state is clicked, draw it above the map. So when I click on a state, whatever that state's name is, Arizona, California, whatever, I'm going to draw it above the map in this little pop-out box. So if a state's currently above the map, let's delete it. We'll first delete it. So we'll delete the box with the state inside. Then we're going to create a glyph. Okay, so the glyph is going to have a rectangle. Okay, it's going to have, so that's a rectangle. It's going to have a text, right? So you can see that the name of the state is there, right? So we'll attach the name of the state to the text. And then we're going to draw, well, Wyoming's kind of boring. Let's do a more interesting state. Where's Rhode Island? There we go. There we go. Right. Then we'll draw the shape of the state inside the box. And so we got to fit the state so it doesn't go outside the box, right? Okay, so how are we doing that? So we have our USA GeoJSON data set, which is, right, our USA map data, right? So these are all the state borders. So we're going to look at the, there we go, okay. Just needed to relax for a second. So features is an array. It's going to be a list of 50 states, right? So each item in the features array is going to be one state. So filter is we're only going to look for the state that has a name that equals like the current state I clicked on. So if I click on California, this is going to return only one state with a name equal to California. So same thing here, whatever state I click on. That's how we're going to filter out of our 50 items down to 1. Then we're going to create a new GeoJSON data structure with only that state, right? So a GeoJSON data structure with only one region inside, the current state that we clicked on, right? So we're going to stick that in there. Then we're going to create another projection, okay, because we don't want to use the Albers USA projection, right? Because it might move it around kind of funny. So we'll create another projection that fits inside this box right here. So you can see I say 140 by 120 pixels, so that the state has to fit inside that box. Okay. All right, so that's what I'm going to use for this GeoPath. So then we'll just draw that state on inside the box like this. We'll append it to the glyph. Using that little state-specific GeoPath. So that's how I'm going to extract a state and only draw its data. Okay, so that's how I'm doing that functionality. And if I click on the box, it actually it'll remove it. So if I click on the box, I'll remove it. So that's why I can do that. Okay, last thing for this example, if the checkbox is checked, add cities from our state capital CSV file to the map. Notice how the XY positions are positioned. Notice how the XY positions are positioned based on the map projection. Okay, so if I click Show Cities, okay, I will append the circles, and I'm using the projection just like a D3 scale, like a scale linear, right? If I draw a scatter plot, I have a scale linear to kind of figure out where their monitor pixel space is. Here, I'm using our map projection to do that. Okay, so again, a projection is very similar to like a scale linear, except it's based on the, projecting a 3D world down to a 2D display. So if I go back to that GeoAlbers projection, let's see if I do that. Where did it go? It's like way up here. Yeah. So if I do this, save that, and click Show Cities. All right, so again, you can see that because I'm passing the states through that projection, right, they're going to draw correctly. So I can even, let's try this. Didn't even plan for this. Let's just see if it works. But I could try another projection. GeoMercator. If I save that, all right, so this is like a normal Mercator projection. But you see how, like in a Mercator projection, right, the US gets put over there. Right, so it'll position it like that. So that works too. If I click Show Cities, right, they all get, the US is so small at this point, they kind of overlap. But yeah, that would work too. Go back to the one on the default. All right, any questions about this second example? So this may be all we have time for today. We may just not get into the lecture at all. Okay, so last example, leaflet. So using Leaflet for maps. So this is an alternative to, right, so for the above two examples, we imported a data set that was the shapes of either the countries or the states, right? So there's a GeoJSON file that we had to import. Here, we're using the Leaflet library to import a bunch of image files, and then the Leaflet library will stitch those together so it looks like a map. So it is a map. All right, so that's what's happening here. So if you want to use Leaflet, the first thing you have to do is you have to link to their CSS and JavaScript files. So I'm already doing that up at the top of the page. Then, so we stick a div where we want our map to be. Then we create a map using a Leaflet function call, l.map, with some other stuff. And then we can, if we want to, we can add tile layers to the map. So other things. Or sorry, the tile layer, sorry, that's the image, the tiles itself. And then if we want to add other data items, we can do that too. Okay, so Leaflet uses OpenStreetMaps for its tiles. Have y'all anyone used OpenStreetMaps or looked at it before? Anyone familiar with it? It's a pretty cool site. So it's kind of like Google Maps, OpenStreetMaps. So it's kind of like Google Maps. It's an open version of it. They have lots of different, let's see, Phoenix. And so if we go into Phoenix area, but they have different tile layers that you can use. It's all open data, so it's kind of been crowdsourced, put together. It's pretty cool. So these are the tile layers that you can attach. Okay, so what are we doing here? All right, so again, we have some HTML. We have our header. We have a Leaflet map div, which is right here. So this is set inside of a div, not an SVG, but a div. Okay, so you can see the width is 100% and the height is 600 pixels, and we're just giving it a border. All right, so not an SVG, but a div. Then we have a function draw leaflet. Okay, so this is getting called. So this is actually called up above when we draw our USA map data. So we're going to call, that's what actually calls the draw leaflet function. So the reason that we call it there is that you might notice I've got this little blue pin here. So that's based off of the state capitals table that I imported. So you can see all of the state capitals have been marked on the leaflet map. And that's because I'm reading that data from the capitals table that we're using on the previous one. So that's why we call this function from there, because we wait until we import the data, then we draw the leaflet map. So otherwise we wouldn't have the data yet. Okay, so this will create the leaflet map. So we say l.map, then we set the view. So we give it some latitude and longitude. And so that's just, we reload. Right, so it's just centered on Phoenix. And then 9 is going to be the zoom layer. So if we said something like, I don't know, 19, right? Maybe it doesn't go that far. Oh, yeah, it was way in. That's a little too close, maybe 10. So that's gonna create our map. We'll add a tile layer to it, okay? And then for each of our list of capitals, right, this USA cities data that we imported above, for each of them, we're going to create a leaflet marker and add it at that capital's latitude and longitude. And so leaflet will add that using, as a little drop pin, okay? Now, the leaflet site has a lot of really good documentation. There's lots of examples of ways to, of ways to add other, to manipulate these maps, to do custom icons, to add tooltips, to do like, things like choropleth maps. You can even add D3 on top of a leaflet map. So there's, we're not doing that here, but if that's something that you wanted to do, like for your project, again, probably the easiest way to do it is just to Google like adding D3 on top of a leaflet map. And there's some examples of how to do that, how to overlay those things. But yeah, leaflets it's a really cool library, worth playing with, worth thinking about if you're doing maps for your projects. Okay, so let me stop the recording. And end our Zoom meeting.